Horizon proves that Earth is a globe and it debunks flat Earth.
The horizon is where the earth or the sea meet the sky, where if you look slightly up from that angle, you will see the sky, or slightly lower and you will see the ground. Or geometrically speaking, that's where your line of gaze is tangent to the ground, where it will just touch the surface of the earth before extending out into space. And on a globe, we can calculate where that is. We just need to know the radius of the earth and the height at which the observation is made. So at 6 feet, you can see about 3 miles. And you can see further the higher in altitude you go, which is exactly what we observe. The height is the only difference between these two photos. As you increase the height, you can see further over the curve. Now, if Earth were flat, none of this works. The line of your gaze is parallel to the ground, and the ground will only meet the sky, I guess, at the ice wall. So let's say that I'm in Los Angeles, and I look out across the flat ocean at the ice wall, which is about 8,000 miles. So to calculate the flat Earth horizon, I can still use a squared plus b squared equals c squared, but the hypotenuse will be basically the distance to the ice wall. And gaining any height won't add any advantage. It won't let me see further. In fact, gaining height on a flat Earth requires you to see further and further the higher you go. But the horizon never changes. So this effect is a total mystery on a flat Earth. And you can't zoom into the water and see through it.
So here's a fun experiment to determine if the Earth is flat or not.
Go to wherever you have a straight view of the horizon at sunset, lay on your stomach, and jump up the moment the sun drops below it. And you will see the sun again. This person here is doing it with a drone. The sun is gone, and his drone goes up to see it a second time, because you can see further over the curve with height. This is not possible on a flat Earth. So just like that, you prove that Earth is not flat, and you observe the curve. It really is that easy, and anyone can do it.
And this is when flat earthers will start to panic and start bringing up like the limitations of our eyes or stuff like perspective or vanishing points. But surprise, flat earthers don't know what terms mean or how sight works.
First of all, the vanishing point is the apparent convergence point of parallel lines. Nothing vanishes. The vanishing point is at an infinite distance because parallel lines don't actually meet. As much as flat earthers bring up crepuscular rays, you think they would understand this, where parallel lines of sunlight appear to converge at a point. Except here, they don't like to talk about perspective. So vanishing points don't exist here, because vanishing points only apply to parallel lines, which don't exist here for some reason. So what, you think we can see forever? Your eyes can detect light that has traveled for light years. Your eyeballs don't need to leave your skull and meet light halfway or something like that. You see, light reflects off of objects or is emitted and can travel for millions of light years. The light does all the work for you, and that light will pass through the cornea, which will bend the light rays to allow light to enter and reach the back of the eye to tiny nerve cells, which convert the light into electrical impulses, which then travel through the optic nerve to your brain. And the brain interprets the electrical impulses as images. The only limit for your eye's detecting ability is that the light has to be within the visual spectrum. We can't see radio waves no matter how far they travel. What flat earthers are looking to save them is angular size, or the apparent size of an object, where it gets too small for us to resolve it, which is about 1 arc minute. And we can calculate when that happens to any object with this formula. So let's say we have a soccer ball that's about 22 centimeters in diameter, and 1 arc minute is about 0.003 radians, which gives us 733 1/3 meters. Now, they used a more accurate formula, which gave them 756 meters. But these are approximations that tell you will start to lose track of a soccer ball around 0.46 miles. So if you were in the back of Ohio Stadium, you'd find it very difficult to see a soccer ball right about here. And it doesn't disappear from the bottom up. It just shrinks to be too tiny to see, which obviously doesn't occur with our sun or moon. They maintain their size as they slip below the horizon. And trying to zoom into the water isn't going to let you see through it or bring back the sun. So what about a large cargo ship? We just plug the average height into our formula, and if Earth was flat, you'd be able to watch it sail away from you for 119.945 miles before it got too tiny to see. And again, it's not going to disappear from the bottom up. Now, if the flat earther is hoping that atmospheric lensing would help them, it will not. It actually helps you see 8% further away. Hey, how far away would Mount Everest need to be for us not to be able to see it? That's a great question. Approximately 18,328 miles. Wow! So in Los Angeles, you should be able to see it in the distance. Yep, if the Earth was flat. But maybe all of like the air pollution or okay, never mind. Yeah, that's pretty clear skies there. I mean, that's a really sharp horizon. It would be all hazy or something with pollution, right? We'd see it blocking our view, and we don't.